We are ready. Let's go with.
It is now time for the students with the last names that begin with I through K. Again, students with the last name I through K to go to the track, the main gym, for their photo be taken.
Avery, I don't think you get rolled very often when we do rolled. I know you got rolled one time. Even though one is like the most common rolled number for some reason, I think you've only been rolled once. Am I correct? Okay. I mean, I would ask in here who hasn't been rolled yet, but most people don't volunteer that, so. What I was hoping you could tell me, Avery, in that big, huge box that's like outlined and, like highlighted, it's like trying to emphasize it. It says differentiability at a point. I guess my word to you is, what does differentiability mean? We've used it a handful of times by now. You can whisper things, go ahead. Is it what? Kind of. We have a word for that, though. We have a word for how fast things change. No. You guys aren't Avery. Oh, a lot of people up here whispered it. There's a word that specifies and specifically means how fast something changes. Starts with an S. Yes, nice. Differentiability. Okay, that's not a marker. Differentiability means that you are able to find the slope. So differentiability at a point means, does that point, are you able to find a slope at that spot? So we've only seen a couple examples so far of places where you couldn't find slope. Does anybody kind of remember what they look like? A sharp point was the most common one. So a sharp point, it doesn't have to be from absolute value. Sharp points frequently are from piece functions. A lot of times when you get fraction powers in a denominator, that can cause sharp points.
Could you find like the slope of a vertical, just like a straight line?
So,
Or is it?
that technically no. If you have a vertical line, like the one example we had, that has no slope. And so I don't think there's really a uniform correct way to say that, because some people will call it undefined, some people say no slope. Undefined is kind of a tough word because that can also mean that you're just not able to find slope at all rather than vertical. So however you want to define it, it doesn't have an answer, but yes. Let's see, what else? Okay, I suppose I can just actually like scroll down to get to there. This says it's differentiable at C if and only if. Oh, this feels bad. This feels like we're going back to geometry. That's the IFF, if and only if. The limit as x approaches C minus of f of x minus f of c over x minus c. Avery, do you want to call on somebody, or should I just like pick somebody? Okay. Who else has not had to answer much? Fiona? you remember this thing that I just circled in red? Do you remember what is that? Like, you should recognize that in full. I guess it's probably the easiest way to say it. Do you remember what that is to find? Excuse me. I think so, yeah. Okay, that's okay. Do you want to help her out? Yes. Let's go back to Avery because she's really an expert at that word. I am. I was hoping for what you answered. Slope. So what I circled in red is going to be the slope to the left of C. That's what the C minus means. So this is the alternative form of slope. Try to remember we're recording. This is the alternative form of slope, so you should be kind of familiar when you see it and know what it stands for. This doesn't even mean you have to find that answer that way. Just the fact that looking at that, you kind of recognize what it stands for. And then over here, this would mean, okay, Fiona, I'll go back to you. Now that you got the answer on the other one, what does this one mean? So the one over here was the slope on the left-hand side of C because it had C minus. So then what would this one stand for? It's got a C plus. The slope on the right-hand side of C. Okay? All this is saying is if the slope on the left and the slope on the right are the same. Now, it does technically say equals L, and this makes it look like continuity, because continuity was three things. You'll see underneath it says L is a finite value. It says finite value because it can't be infinity. It can't be straight up and down vertical. It's not differentiable if it's vertical, even though, like, that's a number. So as long as the slope on the left and the slope on the right have the same answer, it's differentiable. That's what this whole box is trying to say. And that's the approach and how we're going to figure out if something is differentiable. I see a lot of blank looks, and I don't know if that's because you guys tuned out or you don't know what I'm saying. Just keep moving on. Look at you guys put mustaches on, and all of a sudden you're like adults at meetings, so they pretend they're there and they don't pay attention to anything being said. Not that I don't do that personally. Weird. Is that like a common to mustaches? Like you go to a meeting and you just don't pay attention? I'm not going to like discriminate people with mustaches. Okay, we're going to look at absolute value of x minus 1. Let's go, James. James says, what is f prime of x as x approaches 1 minus? What is that actually even asking me to figure out? Yep, the derivative as x approaches 1 from the left. Derivative is absolutely correct and the right word. So what are you actually finding when you say derivative? Slope. Okay, so what is the slope on the left-hand side of 1? Basically like right here. Oh, that's so hard to make a tiny scribble. That's what I would say too. And it is going to be exactly -1 because absolute value of x is made from 1x, which is the slope of 1. Okay? Mikkel, how about B? That's what it looks like to me too. The right-hand side of 1 looks like a positive 1 slope. Good, good, good. Who haven't I picked on from? Andrew?
It is continuous.
Why that look? Why, like, you look upset that I chose you?
No, I was proud that you did, but it's okay.
Okay, is it continuous?
Yeah.
Yes. So continuous just means there's no holes, there's no discontinuities. This is actually really hard writing with my mouse, but I'm impressed with my abilities. Do the other Andrew? Is that what somebody said?
No.
I was pretty sure I heard that. Andrew, is it differentiable at 1?
Yes,
How come?
because the slopes on both sides are the same.
You gave the right answer, but not for this problem. So your explanation was great. But these two numbers aren't the same. That was where it faltered a little bit.
They're both approaching the same. I don't know.
Oh, so what you were answering was continuous.
Oh, one's positive, one's negative.
Yeah, they're not the same number.
Yeah.
Yeah. So what you were kind of answering was continuous, I think. They were both approaching from left and right, and they met each other, so that's continuous. But they don't have the same slope, so differentiable, no. Now this specific example is here because in a couple pages we're going to get to the part where you're going to be asked, is something differentiable automatically if it's continuous? The answer is no, because it could look like this. So just because a function's continuous does not mean it's differentiable. It doesn't mean it has a slope answer everywhere. I don't want to do that one. Don't really care about that one either. It doesn't really. They are practice examples. I want the practice examples currently that specifically talk about differentiability and continuity. Those don't. I mean, they're there for practice, but they're not getting to what I wanted to talk about. That's what I meant by I don't care about them. Every teacher kind of has a different perspective in the way they teach things. So the person that made this packet has a way that she tries to explain them. It's not always the same as it's basically how every person thinks differently. They can all look at the same problem and view it differently. Okay, differentiability implies continuity. This is probably the most horrible thing for you guys to try to read through. It's got so many big words in it. Does anybody feel confident enough that they can explain what this is saying? Zara?
Everything with differentiability also is continuous, but not everything is differentiable.
Very good. I know, the words are hard to use correctly, and you guys don't use those words enough to know the correct form of the words and everything, right? That is exactly what it says. So if something is differentiable, that means it has a slope on the left and a slope on the right that's the same. Well, the fact that it has a slope means that it also has a point, right? Like slope means how much it changes. And that absolutely implies that it has to be continuous because you can't have a slope if it's not continuous, right? Like if your pieces don't meet up, you can't have slope there because it's not the same graph even. So the fact that if something is differentiable automatically means the graph at that location is nice and smooth. This is kind of a horrible topic to just keep talking about because so many of the words sound the same and you gotta get them straight in your head. But on the AP test, that's what they do. And that's why we try to use all of this verbiage so much. Because on the AP test, they're gonna give you weird problems where in the directions it might say, f of x is differentiable at x equals a. And then it'll ask you something else about this, that it is going to specifically be asking about continuity. And normally you have to try to prove if something's continuous, etc., or just figure it out. But the fact that it said differentiable in the directions means you have to automatically know that it's continuous, and so you can do the problem with that info. And that's usually how they're going to use it. Whether it's right or wrong, whether it's tricky or not, I don't know. But that's what they do. So that's why we have to learn the difference between them. So these are the main examples that you run into. Sharp corners, cusp, which is also a sharp corner, but one side is curved. Vertical tangent line, which you've seen, and you've seen discontinuities. These are kind of the different situations. Okay, number 4. Christian? Are you ready to shine? No. Why not? Why would I know that? So you're saying right today's probably not going great for you? Okay, so I should pick somebody else. Okay. Out of excuses, that's a pretty decent one. But usually they let us know. Like, did you let the school know?
Trained yesterday.
Oh, okay, they just haven't sent it to us yet then. Yeah, usually they do. Is there anybody I haven't called on? Let's see if people are actually honest. Wow, you threw them under the bus like that?
We're a package deal. We work together.
Oh, did you point at her too? She's been called on.
Yeah.
Oh, you've answered before, haven't you?
Yeah.
Maybe I just haven't called on you?
Yeah.
Oh, okay. Well, Ian was also thrown under the bus. Yeah. It's okay. You gotta let everybody see your glorious, yeah, your adult form. Although you're supposed to be like senior citizen, aren't you? No. What grade are you in?
I'm a sophomore.
Oh, God, I was right on. Okay, you're an old-looking student. I was hoping you could go up to the board and write that answer. You guys look at me like I'm supposed to know how old people are.
Yes.
Like, you guys are all completely mixed and thrown together, like I just automatically know how old you guys are. Oh. Did you want to go up to the board and we can guide you a little bit?
Was it, like, example 1, is this sort of basically that one? Just different function? Equation?
Sure. I mean, they're all going to be like example. I mean,
Oh, and I had one question earlier.
oh, sure, now's a good time to ask. Yep, okay.
For the equation.
Okay.
So it's like, x squared minus 5.
Yep.
So like in example 1 3, what is, the x towards 1 and then 1?
Okay.
You got that 1 from here, right? So
Oh, that's why they chose 1,
so
yes.
would it be 5 here?
It'd be square root of 5, actually. It's plus and minus square root of 5 are the zeros. Oh, true. You do need to know that for the answer, I guess. Yeah. Do you guys know how to figure out where it crosses 0? You set it equal to 0.
Yeah.
So x squared minus 5, just the inside. So x squared minus 5, when you make that equal to 0, would give you plus and minus square root of 5. The other one was just a regular number because it was just a regular x. This one's squared.
All right.
You add 5 to both sides, take square root. You look confused at where the plus and minus square root of 5 came from. Thinking. If you want some guidance, you can ask anybody in here as well. Being in the front of the room, you are in charge. Whoa, what are you writing?
Well,
Can you start? Like, can I just write this?
Whoa, back up. What are you writing?
Is it A, B, C, and D?
I don't know what that says. Oh my, what is going on? Oh, I don't know what's going on. Let's, oh, here, don't tap, don't tap. It definitely happens to me too, and I have no idea why it does it. But apparently, it looked like you did some sort of gesture and it made it, we might have to troubleshoot later and figure out what you did.
Do we do like the ones that set equation to zero, so f prime of x as x approaches the square root of 5?
You're thinking way too much into this. So he was just,
I shouldn't write that? The f prime of x, x leading towards one, or, I'm confused, I thought I was. Am I not supposed to write this?
Where it touches the x.
ah, you don't need to write that at all.
I don't need to write it?
Got it.
So do I just write here, the answer? Straight up?
Do you want me to just write an answer up there? It's okay. So if you weren't sure what it was even asking, I can take over.
You remember, so you have to say
Ah,
equal to zero.
so that's what you were trying to ask me when you said, is this like question one?
Yeah.
I understand. So question number one just asked you, is it differentiable? And if it asks you if it's differentiable, then you find the slope from the left and right. And if they're the same, it's differentiable. If the slopes are different, it's not differentiable. This one already tells you it is, and more like it says, say where the graph is differentiable. So if we're looking at this graph, where is it not differentiable? At the sharp points. Those two spots are the, I hate this thing. Those two spots are the only locations where it's not differentiable. The slopes are different from either side. Sharp points will not be differentiable. Okay? What we're supposed to answer is, where is it differentiable? Well, we can find slope anywhere else but those two spots. So we can find the slopes from negative infinity up to square root of 5, negative square root of 5. Why does it keep moving? Along with negative square root of 5 to square root of 5. And then from square root of 5 to infinity. So I can tell you were kind of just going about it from a different perspective totally. If it asked you, is this differentiable at negative root 5? Then you would do what you were trying to say, where you would say the limit of f of x at negative root 5 from the left is this answer, the limit of f of x at negative root 5 plus is a different answer, and then it wouldn't be differentiable. But this wasn't asking you to prove or to say if it is differentiable or not. It just said, where is it?
We need to be able to do this without the first.
Yeah. Eventually, not yet. So absolute value of x squared minus 5, you know it's always going to be positive. What you're going to do is we're going to learn how to take derivatives of whatever kind of equation, whether you have a picture or not. So we would be able to take a derivative of this later. Absolute value equations can always be rewritten as the square root of the square. So we would actually rewrite this equation like this. That's the definition of absolute value. We could rewrite it like this, and then do derivatives when we learn an easier way to do derivatives. This problem would be almost impossible using the limit method. This is too complicated. Okay, sorry. I wasn't trying to throw everybody off. I just, does this make sense what we're trying to answer up here? Are you asking where I got negative square root of 5 from? Yep. Yep. The square root of 5s? The square root of 5s came from this. Absolute values will always change directions when they switch from negative to positive.
Excuse the interruption. Students with the letters that begin with L through MA, please go to the track if you need to have your photo retaken. Again, students with the letters, L through MA.
Absolute values are where it changes from negative to positive, so what we do is we look to see where this is equal to 0. And so when you solve that, add 5 to both sides, take square root. That's where that number comes from. Yep. Okay, I get it where some of you may not need the question that's asked. But it makes it extremely difficult to teach when you start talking to other people while I'm trying to explain one that was asked. Because then they can't hear. Oh, this looks terrible. We definitely need to do this one. No. If we set them all equal to 0, that just finds the zeros. And that doesn't always help. We did it on the last problem because absolute values will always change direction at a 0. So that's the only reason we did that one equal to 0. Should we draw this one first? Would that help you?
Yes.
Okay. And I'm gonna guess you guys need some assistance drawing this. Okay? You'll notice that the quadratic ones are written in vertex form. That's the benefit. Oh, I didn't write it. I wouldn't give you the benefit of it. I'm not that bad. Yeah, I don't think I made it big enough. No, that one is a 4. Let's go by 2s. Sure. You see, it's by 2s, it's by 2s. There. Now it's big enough. So the first one I'm gonna graph, I'll try to color code these. X plus 1 squared, but only to the left of 0. Including 0, but, so x plus 1 squared, do you guys remember transformation graphing? What does the plus 1 on the inside of the function do? Moves it to the left 1. So this is gonna be x squared, so parabola, to the left 1. So instead of being at 0, 0, it's gonna be a negative 1, 0, and then it's gonna follow a normal parabola shape, which is over 1, up 1, over 2, up 4. Is that how you guys graphed it last year? Doesn't completely sound like it, but that's how you do it.
Should that be by 2?
I did go by 2s. Oh, I put the center at negative 2. I'm sorry, that's what you were saying? And you are correct. This is why I don't normally go by scale. Yes, thank you. Sorry to screw you up like that. Over 1, up 1. Over 2, up 4. So the left-hand side, super easy. But the right-hand side is only gonna go over to 0. So I'm gonna have over 1, up 1, and that's where it stops. And it's gonna be a filled-in circle. Okay. So that's the first piece. The second piece is gonna be a straight line in between 0 and 3. Because it's a straight line, I'm just gonna graph 2 points, the beginning and end, and then connect them. So I'm gonna plug in 0, and so I get the point 0, 1. Convenient. On top of the other one. Then I'm gonna plug in 3 and get 7. Well, it's a good thing I made this by 2. That one's filled in. It's so hard drawing a straight line up here. So the red one was filled in. The green one on top of it was open, so that they weren't overlapping. This one is, oh, I'm sorry, I wrote the wrong one at 3. At 3, it's supposed to be an open. Open one. Correct, when you make a piece function, they can't overlap. this one is did you guys do horizontal reflections? Sometimes you do it in pre-calc, sometimes you don't. This one has a horizontal reflection, but, well, that's, doesn't matter on the problem, it's symmetrical. So, it's not gonna look any different. So it's gonna be 4 to the right though. So 4 to the right. It is not raised up, so it'll be on the axis. And then I'm gonna follow the normal parabola shape. I mean, it's obvious, it's flip back and forth, but that doesn't matter. So, over 1, up 1, filled in circle? Yeah. Over 1, up. Over 1, up 1. Over 2, up 4. Okay, so if you know what it looks like, that's what it looks like.
Why does it stop on the left side?
Because this says we're having this graph only starting at 3. So I was going to the left, I guess, so it feels different, but technically it started at 3. I don't know, ask questions about the piece function first, though, I guess. That's gonna be probably the most difficult part about it. Like, you guys are gonna have to be able to make them on your own.
Why are the holes so big for
The green one? Just because both of those inequality symbols are less than, they don't have a line underneath them.
Oh,
Yeah, the line underneath them would mean you filled it. And these will always be written so that nothing can ever be at the same location twice. It wouldn't be a function otherwise. Okay, but the original question, find all values of x for which the function is differentiable. I guess to me, there's only 2 spots which I'm not sure about. Because it's obviously makes smooth curve everywhere on the colors. But the locations that we're unsure about, I can draw a dot, but, you know. I'm unsure about there. I'm not unsure about here, but I know that that one's not differentiable. I mean, they can't be differentiable if they don't connect, so. How do I figure out if that green and red location is differentiable? What am I supposed to try to figure out? Slopes, okay? Eli, you must be looking up the answer. How do I figure out the slopes on both sides?
Just draw a tangent line.
Ooh, that sounds good.
Or you can, I mean, you can look at their function and put it in point slopes one, just look at the slope.
That will be difficult on a problem. Easy on the straight line. But, so the red one is the one that we're looking to try to figure out. The limit of h of x. Let me rephrase that. The limit of h prime of x as x approaches 0 minus. So the left-hand side. So the prime symbol there means I'm finding the slope. The green one is the same thing, but finding the slope on the right-hand side. So h prime of x. Okay, Eli, what's the slope of the green line?
Like 2.
2, it's exactly 2. Because it's in slope-intercept form, we know that answer. Now, I'm not fully expecting you guys to be able to figure out the parabola one. Some of you could figure it out probably on your own by just logic. We did the derivative of x squared by itself a bunch of times. Remember doing that? The derivative of x squared is 2x. But this is shifted over 1. So you would need to figure out the slope at positive 1 on regular x squared. So you could figure it out that way. Like that would be like just figuring it out by deduction. I can tell you that the derivative of x plus 1 squared is going to be 2x plus 2. So I would plug 0 into 2x plus 2. So if I plug a number into x plus 1 squared, that would tell me its height. It wouldn't tell me its slope. It would tell me the height of the function. So I would need a derivative equation to plug in a number. And that's kind of why I was giving you that equation, because that's the equation of the derivative. So the slope at 0 on a parabola x plus 1 squared is 2. Oh, I don't like that I made those 2's different. Correct. If something is not continuous, it can't be differentiable. And that's why those statements start getting weird. Because if it is continuous, that doesn't mean it's differentiable. It starts getting kind of odd. What makes it easier is if you know what continuous and differentiable means.
Where did the 2x plus 2 come from?
I knew the answer. You're not gonna be able to figure it out yet. Okay, you could have taken the time to do the difference quotient derivative.
Oh, that's how you do it.
Yeah, I know that's the answer.
So say you have like a function of a limit that's not differentiable, because it's not continuous,
Correct.
but the slope will exist, doesn't it?
The slope on each side does exist, but the fact that it's not continuous means you can't find the slope anyway. So slope kind of implies that how fast something is changing, and that would require a point before and after it to say how it's changing. And so if there's no point after it because there's a hole, it's not changing.
Will you give us an equation of how to find the difference quotient to 2x plus 2?
For what? For later?
Or like on the test or something.
I don't know. I just did it to save time. Like I didn't want to take an extra 5 minutes for you guys to figure out the derivative.
So we would find out the derivative.
Probably. I don't think you're gonna get equations that are really gonna be a big deal though. I don't think it's. In one section, you'll learn how to do the derivative without work, so I guess that's the plus, just not this section. Okay, but going back to my question, is this differentiable? Yes. It actually is differentiable at x equals 0 because it's the exact same slope on both sides. And it's kind of weird because one's a curve and one's a straight line, but basically that curve goes right into the straight line. It goes in so smoothly that the rate of change is the same.
So you would say it's different.
It is differentiable at 0. The only place where it is not differentiable is 3. So the differentiability answer, I think that's what you're asking, would be negative infinity up to 3 and 3 to infinity. Yep. Yep.
So I understand the math behind it, but like how could the slopes be the same?
So slope just means how fast is it changing.
Okay, so I thought it's
So-
still like going different directions.
If you think at a microscopic level, 1 point, the next point, a slope of 2 means the next point will be over 1 unit of 2 units. Well, on your parabola, that's the exact time that it's changing at that rate. And then you go immediately into a straight line, which also goes over 1 up 2.
Okay, got it.
And so this would be like x equals 0 right here. And so it's changing the same right before it and right after.
Okay, got it.
It's kind of weird, but that's like how you can think about it in your head. How's this one?
So why aren't the red and green lines like the same?
What do you mean by the same?
Like, if the slopes are the same, why would they look the same?
If I drew this with all one color and nothing different, then what you would see is a parabola that looked like it went exactly into a straight line. And you really wouldn't even notice the change too much, other than instead of still curving, it would stop curving and go straight. So you wouldn't see, I just did it in colors so you could know where it came from. But I think maybe what you're getting at is the rate of change before that isn't 2. The rate of change after that is 2 repeatedly. All we're trying to say is that we're able to find a slope answer everywhere but where they break apart. It doesn't mean they have to look identical. It just, there's a slope answer.
How would you know which one to check?
Well, like on a piece function, you pretty much guaranteed check where they break. Then the next thing I would look for is, do any of these individual functions have, like, divided by 0? Like, what's the word? Discontinuities. You would have to look at that in each function individually too. Why? Oh, absolutely, go. It doesn't even matter if we go whether we're doing it or not. Plus, I think it's in the hour. That went by fast. I wasn't expecting it that fast. You could probably basically do all of the homework from here. Because the homework is all about, is this differentiable or not? I know there's some more examples, some harder than others, but they're not necessarily, this is basically what we just did when I tried to show you algebraically why it's differentiable. I can. I mean, there's nothing specific I have to go over anymore. One thing I did want to cover, which I didn't have time for, is the calculator. If you want to use your calculator to find the slope, the directions to how to use your calculator are in your notes.
We're not
This-
allowed to calculate on the test.
No. Well, your calculator is just to help you learn. It's not like it's supposed to be your savior. It is a tool, but some people use that tool as their like lifeline, and that's not a good use of it. So you can use your calculator to check your work, basically. If we do more notes, it'll only be like 5 minutes, and then the rest of the time will be for work.
Who wants the ticket?